All right, we're looking at topic 1, lesson 2 right now. It's not subtract integers though. This is, I'm drawing a blank on what it is, and it's not subtracting integers. Wow, cool, a couple of errors already. We're looking at though rational numbers and how do we convert from converting numbers into decimals. So two words that we've got here: terminating decimal and a repeating decimal. Terminating means it does eventually terminate or stop. So you got it ends in 0. So 0.65, 0 is something we can imagine as there. 9.0 or 0, those have zeros at the end. So they are a terminating decimal. When you're doing the, what's it called? Long division, and you get something that, you get a 0 at the bottom eventually, that's a stop, right? That's a 0 that comes there. And then repeating decimals, those are when you have a decimal expansion and it repeats over and over and over again, or the same block is going to repeat. So right here we have 0.66, a little line over it means that it's repeating. It could be something like 68, 68, 68, so that 6 and 8 are repeating, so you can put that line over it too. There could be one where it could be 0.1234, 1234, 1234, so like 0.1234, 1234. Like this right here could be repeating. So you can put that over all of those. You can put your line over those digits that are going to be repeated. So let's look at a couple of them. We're going to do a couple of examples here. Key concept is the same thing. To convert from the fraction form of a rational number to its decimal form, divide the numerator and the denominator. So we got 3, let's do example 3 over 4. Denominator is on the bottom, so we go 4, like that. So 4 goes into 3 0 times, and so we can actually put a decimal there and carry that decimal up. Now, how many times does 4 go into 30? If we think about that as 30, 7. Pretty sure I don't need to explain how to do that. So this is now 20. And then we got 5. 5 times 4 is 20. It ends in 0. I get 0 down there, so it is done. So that is a terminating decimal. It stops. There's nothing left to it. Example of 1 over here, you got 1 over 6. So if I go 6, it does not go into 1 at all, so we're going to put a decimal there, make it a 10. So 6 goes into 10 4 times. 4 times, oops. Does not go into 10 4 times, it goes into 10 once. And then when we bring that down, goodness gracious, 1 times 6 is that. So then we got 10 minus 6 is going to give us 4. That's where that 4 was coming from. Bring down a 0, we are at 40. 6 goes into 40 8 times, no, 6 times. 6 times 6 is 36. Subtract there, we're going to get a 4. So if we kept on doing this, we would keep getting 40, 40, 40, 40. So it's going to repeat. So we can look at it right away without even needing to continue. We would continue to get a 6 up here. So we're going to say that 1/6 converts to a decimal that is 0.16 repeated. This first one's this first exploration here is pretty easy. He's got 2 surfboards. He wants to look at what's in the middle of those. You've got 2 numbers. The first model is 22.5 inches wide. And his second model is 23 1/4 inches wide. And all it states is he wants to get something that's between those 2. So what's a number that's between 22.5 and 23? An easy one is, oops, that's a bad little bracket there. Yeah, you get the idea. A number that's in between those is 23. It could also be something like 22 3/4. It could be 23 1/8. Like any of those numbers on the inside of that. It's just asking, what are some possibilities for those? Example 1, I'm going to go fast to try and beat the bell. So Juanito's doing some math to calculate his fastballs. He threw 52 out of 80 fastballs. 52 fastballs, a total of 80 pitches. So we can do this and calculate what is, if you did 52 out of 80, our problem is going to look like this, 52. Long division would be 0. The next one is 480. Do our math here, we got 40, we got another 0, we're at 400. This is 6 and then 5. So 5 times 80 is gonna get us to 40. So we got 0 down here. So that means that that number is done. It terminates. Here we got a class, they're voting for a new mascot. 5 out of 18 votes are to change the mascot. So how many times does 5 go into 18? You get 3. What am I? Did I do this one right? 5 out of 18. Oh. 5 doesn't go into, or 18 does not go into 5 at all, so we gotta have our 0. Sorry about that. So 0. So how many times does 18 go into there? 18, 36, 52. So it only goes in there twice. 36. So we get down, we've got 14. Oh goodness gracious, we're gonna get some big numbers here. I'm trying to do this fast. We're gonna get somewhere around 22%. My mental math is going to be slower than the calculator at this point. 940. So it's going to go into that 7 times. So 7 times 18. Is 126. So when we get our math there, how many is going to be left? Well, look at that, 14. So right away we can see we're going to continue to get 140, 140, 140. So we know that that 7 is going to be repeated. Look at that, that's faster than I thought. Looking at this last couple ones here. Explain whether each one is a rational number or not. Rational means it stops or it terminates. So this one, negative 6.382, yeah, it eventually stops, there's nothing there. So this is rational. Right here we have one that's going to repeat, so it's actually called irrational. And then over here, this ellipses means that it's going to go on forever. Similar to pi, 3.14 is going to go on forever. It is a non-terminating, non-repeating decimal, so it doesn't stop. But it doesn't repeat, it just keeps on going. The next digits could be 6, 5, 9, 6, 4, 7. It could be random, completely random. So this one again is irrational. All right, here we go.